morning everyone, my name is Hasdal Basha and I am studying second B.Pharm in Ravindra Institute of Pharmaceutical Education and Research, and today our topic is buffer equation. Now we are going to discuss about how the buffer equation is derived. First of all, we are going to see who was invented this buffer equation. They are nothing but Henderson Hasselbalch. And now we are going to see how the equation is derived. First of all, we need to know what is buffer. Can anyone tell me what is buffer? Nothing but a solution which resists the change of pH. Right? For that, now we are going to take an example. Assume I am going to take a weak acid which is reacted with what? We all know that the example of weak acid is acetic acid. So we are going to take acetic acid which is reacting with water. Now the reaction happens. This is the product and these are the reactions. For this, when we apply law of mass action, this derives from nothing but the concentration of products by the concentration of reactants. For that, first of all, we are going to take the dissociation constant of acid. It is nothing but Ka. That is the concentration of products divided by the concentration of reactants. And see here, the water is very plenty when we take the reaction, and also the concentration of water is very low. So that's why we are going to neglect water and we are going to take only acetic acid. And now see, this is the dissociation constant, and we are going to did the concentration of the concentration of products and the divided by the concentration of reactants. And now, can you tell me which is the strong acid here? Hydronium ion is a strong acid. Recognize this, the hydronium ion is a strong acid. So that's why we are going to derive the hydronium ion concentration. Just doing the maths, H3O plus is equals to, the divided by it comes here to multiplication. And this comes to here division. Okay, sir. And this is the equation what we got next. And now this is nothing but acid and this is nothing but ionized salt. Okay, and now we require here pH. For that, what should we add to get pH here? When we apply negative logarithm to this equation, we'll get pH. So that's why we are applying negative logarithm. See, the negative logarithm of H plus ions is known as pH. The minus log Ka is known as pKa. It is nothing but the particular acidity of a acid constant minus log acid by salt. I required plus here, not minus. So for that, we are just going to flip the equation. We are nothing but we have seen many before classes. Sir is playing with the equations as one, but remember, only through mathematically, not as you like. If you do as you like, it will go to somewhere else. So that's why pH is equals to pKa. Now we have, this is the another equation for OH. For this equation there is another equation, that is pKw. When we apply logarithms, logarithm for this, it will come POH is equals to minus pKa minus log. This is, assume this as equation 1 and this is equation 2. Substitute equation 1 in equation 2. We get minus pKb minus log base by salt. This is the another equation for POH, which describes both pKw and pKb. This is the final equation, but the main Henderson-Hasselbalch equation is pH is equals to pKa plus log acid by salt.
If the right is ionized by
This is the final equation. I hope you all understood. Thank you.
good. See, there is a problem.